Okay, this is page 8 of quadratics. Number 5, match each quadratic function with its corresponding graph. If you look at these are all in some form of vertex form, right? So I'm going to use the highlighter and I'm going to highlight some of the numbers that have to do with where the vertex is. Okay, those are all h and k's. Remember that vertex form is y equals a times x minus h quantity squared plus k, where the vertex is h comma k, and a is a parameter which causes the parabola to be wider or narrower. And if you get some weird one like this, which does not seem to have any h's and k's in it, it means that h and k are 0. Okay? So let's try to figure out then which one of these is which. Let's see. Let's look at the first drawing. The first drawing is a parabola. It has a vertex, it appears at 3, 2. So which are the equations which have h and k, which are 3 and 2? So 3 here and 2 here. Remember, the minus is the standard form here and plus the standard form here. If it's the opposite, then that would be a negative h or k. So 3, 2 looks like it might be this one. And looks like that's the only one. Okay, so if we look at the sign in front, it's negative, and that makes sense because our parabola is upside down, right? So A must correspond to small letter b. What about big B? Big B seems to have its vertex at 1, 1. So that looks like it might be either this one or this one, right? Because minus 1 corresponds to positive 1 for h. Plus 1 here corresponds to positive 1 for k. So this looks like the correct answer, or h. So is it little d or little h? How can we figure that out? Well, the difference between little h and little d is one of them has an a value which is a half, and the other one has an a value which is actually 1. But since 1 multiplied times anything is whatever the original value is, they just erased the 1, right? The a value for h is 1/2, and that has a tendency to make the parabola wider than normal. What do I mean by normal? So like the parent function is the regular old normal parabola function, and it has the values 1, 1 squared, 2, 2 squared, and 3, 3 squared. So that would correspond to 1, 1, 2, 4, and 3, 9. Okay? So if you look at a regular old parent function parabola, I would see it step up from 1 or 0, 0, 1, 1, and then 2, 4. It would go. It would grow at about that rate. And if I look at my drawing capital B, I can see that it does go 1, 1, and it does seem to also go 2, 4, right? You go over 1, it goes down 1. If you go over 2, it goes down 4, just like the parent function. I can see that on the right side too. Go over 1, goes down 1. Goes over 2, goes down 4. So this capital B graph appears to be the parent function, and if it is the parent function, then that means that the a value is 1. So that means my answer would be small d instead of small h. So I'm going to put that my answer is small d. Capital C. Capital C seems to have its vertex at, let's see, -3, because this is -6. Halfway to -6 would be -3. And then the y value also appears to be -3. So I'm looking for something in vertex form with -3, -3, Remember, the h value, if the h value is -3, then it's going to appear as x plus 3 because it would be x minus -3. So it looks like it might be this one. Is there any other ones that have 3 for h and 3 for k? No. So it must be f, small f. Okay. Let's look at capital D. Capital D has its vertex at the origin. So in this particular case, the h value and the k value would be 0. So that means that it's either going to be this one, and none of these others has a h value and k value both 0, right? C has a k value of 2, so that means it's not going to be C. It must be small g. So I'm going to put small g here. And you can see that there's a negative sign for A. So if there's a negative sign for A, that means it opens down, which is exactly what's happening here. So perfect. Capital E. Capital E is the vertex is at 0, 2, which means the h value is 0 and the k value is 2. And the one we just looked at, it's this one, isn't it? Because the h value here is 2. If the h value is, the h value is 0, right? So if it's x minus 0 quantity squared, and that's why we just have x squared here. Okay, and the k value is 2. So this one is going to be small letter c. What about capital F? So capital F has a vertex at 1, 1. 1, 1, let's see, which ones haven't we seen? It must be this one that we didn't use before. It's 1, 1, right? And we can see that's a little bit wider than the parent function. If it was the parent function, it would go over 1, down 1, and then it would go over 2, down 4. It would be about like that. So this parabola is less narrow. It's wider than the parent function, which means the a value is smaller. Okay, so that means that small h is the answer for that one. All right, what about big G? Big G, the vertex appears to be at -1, 3. So let's try to find one that has an h value of -1 and a k value of +3. There's one there, right? H value of -1 leads to +1 here. Are there any others? Nope, that seems to be it. So it must be small a. Okay. What about big H? Big H has a vertex at -2, -1. And that would mean the vertex is here. And we need to figure out which one of the remaining functions could be. So I'm looking for an h value that is -2, so I'm looking for something like x plus 2, and then the k value is -1, so it must be this one, right? This has an a value of +2. +2 means it opens up, and it is taller than the parent function parabola. And that makes sense, because like if I go over 1, normally I would go up 1, right, for the parent function parabola, and this one even goes higher, so that means that I is indeed correct for this one. Okay. And last of all, the only one that's left is E, so this must be small e. Let's verify that. So the vertex here is 2, -2, right? So let's make sure that small e has 2, -2, and indeed it does. And that means that this is indeed the right function. Okay. So that's it for number 5. Let's go down to number 7. Find the x-intercepts for x squared minus 9. Okay, so if we have, if we're looking for x-intercepts, remember that x-intercepts all have coordinates where the y value is 0. So the x-coordinates, the x-intercept could be something like 1, 0, or 2, 0, or -3, 0. These are all possible x-intercepts. And do you notice how the y values are always 0? So the way you can find the x-intercepts for a function is all you need to do is put y equals 0 into the function. So let's do that. So the a is going to be 0 equals x squared minus 9. And we can solve for the x value. We find that by doing algebra. And do you see how we have x squared equals 9? Remember that if you take the square root of both sides of the function, remember that you need to do plus or minus the value. Okay? Oops. Not x squared, just x, because we took the square root already. And so that means x equals plus or minus 3. So it could be x equals plus 3, or it could be x equals minus 3. Those are the two possible x-intercepts. Okay, and there's two ways to think about this one. We could, after we set the y value equal to 0, we could look at this and say, oh, this looks like a pretty easy problem because there's not 3 terms, there's only 2 terms. If there's only 2 terms, maybe I can factor out an x here. So if I factor out an x, I get x times 4 minus x, right, equals 0. And now I have factored form like in the investigation, right? So what 2 values of x would make this expression 0? Well, either we're going to use the zero factor principle, so either the first term is 0, or the second expression is 0. So either x equals 0, that's one possible solution, or 4 minus x equals 0, which means x equals 4. So those are the two possible answers for E. And then, of course, if you have x squared plus 7x plus 10, maybe this could be solved by factoring. We're not going to do factoring right now because if you know how to do factoring, you don't need to practice here. And if at this point, after many years, you don't know factoring, okay, just use quadratic formula. Okay, so A in this case is 1. And the reason why I say that is because factoring is fast in most cases, but there's only going to be 1 or 2 IB problems where you maybe going to have to do factoring. It's not going to make a big difference. If you're going to learn it for SAT or something like that, that's fine. But in this class, we're not going to test you on factoring or anything. So I got that b equals 7 and c equals 10. So if I put that into the quadratic formula, it would give me, remember the quadratic formula is negative b plus or minus b squared minus 4ac. You don't need to memorize it for this class because it's in the formula sheet. Okay, so let's put negative 7 plus or minus the square root of 49 minus 4 times 1 times 10 divided by 2. So that gives me negative 7 plus or minus the square root of 49 minus 40, which is square root of 9 divided by 2. So that would be negative 7 plus or minus 3 divided by 2, which is equal to negative 7 minus 3, which is negative 10 divided by negative 10 divided by 2, which is negative 5. Or I have negative 7 plus 3, which would be negative 4 divided by 2, which is going to be negative 2. So my two answers in this case are negative 5 and negative 2. Let's look at the next one. So in this case, A is going to be negative 2, B is going to be negative 4, and C is going to be negative 2, right? So if I'm going to use quadratic formula again to solve this, I know that x equals this expression right there. So that would be negative 4 plus or minus b squared, so negative 4 squared, minus 4 times negative 2 times negative 2, all over 2 times negative 2. So let's cancel out some of these negative signs. So these two negatives combine together and become positive. These negatives cancel out with each other and become positive. So we're just left with a single negative there. And remember that negative 4 times itself is negative 4 times negative 4. That would give us positive 16. So that one kind of cancels out too. So we got positive 4 plus or minus the square root of 16 minus 4 times 2 times 2, which is, oh, that's also 16. What a coincidence. Divided by negative 4. So that means 4 plus or minus 0 divided by negative 4. So that means the answer is negative 1, and there's only one solution, negative 1. Okay. What about K? So K has A equals 1. Right, 1 there. X equals negative 6, or B equals negative 6, sorry. C equals negative 2. So let's put that in the quadratic formula. Negative negative 6 plus or minus the square root of negative 6 quantity squared, which is 36, minus 4 times a, which is 4, times negative c, which is minus 2 times 4, which is negative 8. So it would be minus negative 8 divided by 2. And so we got some negative signs canceling out here. Those all cancel out. So what we're left with is 6 plus or minus 36 plus 8 is 44 divided by 2, which is equal to 3 plus or minus the square root of 44 divided by 2. If you want to, you could factor out a 4 from the square root of 44. You get 4 times square root of 11, or 2 times square root of 11, because square root of 4 is 2. 2 square root of 11. The 2 cancels out, so you might end up with 3 plus or minus the square root of 11, but IB doesn't ask you to reduce the radicals. So basically it's 3 plus or minus square root of 11. Let's do the last one. So in this case, A is 1, B is negative 4, and C is 1. So we're going to use quadratic formula again. And we have negative 4 is negative b plus or minus the square root of b squared, which is 16, minus 4 times a times c. And a and c are both 1, so you just do minus 4. And that's all divided by 2 because a is also 1 again. And we're going to cancel out these two negatives. Multiplied times each other is positive. So that means we have 4 plus or minus the square root of 12 divided by 2, which is equal to 2 plus or minus square root of 12 divided by 2. And that's a satisfactory answer from the IB point of view. If you would like to change square root of 12 into the square root of 4 times square root of 3, which is equal to 2 times square root of 3, then you can reduce that. It could become 2 plus or minus the square root of 3. And that is the answer for I. And that's it for this page.